start sharing those with you. So ratios that apply to triangles are so useful because they help us, again, find out data about sides that we don't know information about, okay, or angles. So let me go ahead and show you some stuff. Lunar formations. Scientists can use the measurement of the angle at which the sun's rays strike the moon's surface to determine the height or depth of a lunar formation. In example C, you will see how to use a trigonometric ratio to estimate the depth of the crater. Okay, trigonometry, yes. Geometry, yes, that's where we're starting. Do you guys remember, I think it was you guys, that we had a guy and we had a tree oh my word and if the sun cast a shadow on the tree, it created this length of a shadow, and the same, again, sun's still in the same spot from here to here would be the guy's shadow. We've done maybe a building and a guy. We did that a while ago, and what this is today is exactly like that. Okay, except instead of using ratios, which we used to solve this type of a scenario before, we're going to use trigonometry. We're going to use relationships. So, the term trigonometric ratio is the ratio of the lengths of two sides of a right triangle. Okay? A trigonometric ratio is the ratio of two sides of a right triangle. You guys with me so far? Here when we did this, if the guy was, so like if we did tree height, and shadow, and we did guy height and shadow, let's just say the tree's height was 10 and it formed a 15-foot shadow. And if I say the guy's shadow is 7.5 feet, how tall is he? Now, most of you can probably already see what I did there. I simply cut the shadow in half, which gave me the guy. He's a little dude. But this is what we're doing today. This is what we're doing today, only using some other information. Okay, so we're going to start with example 1, and I really, really, really want you to just not worry about this. Go nice and slow with me. You're going to be fine. Okay? The first ratio you are going to learn is called tangent. If you look on your calculators, most of you have trigonometric ratios. There's my tan button. There's also sine and cosine. Okay, and you will learn more about those. Anyway, tangent. On your calculators, it says tan. Okay, on your calculators, it says tan, and you will more often than not see items just written as tan. Okay? To solve a tangent, and we're going to figure out why we care, but the tangent ratio is as follows. In an acute triangle, it is the side opposite the angle over the side adjacent to the angle that we're talking about. Okay? It's the side opposite the angle over the side adjacent the angle. Okay? Let me show you how that works. They've got an example there, but I want to do my own. Okay, let's just say I wanted to know the tangent of angle D. The tangent of angle D. If I was asked what is the tangent of angle D, I need to know the side opposite angle D divided by the side adjacent angle D. Okay, so here's angle D. This is the side that is opposite angle D. Okay, if he walks out, that's opposite. Okay, this is the side adjacent angle D. You might say, well, wait, the hypotenuse is adjacent as well. Adjacent means attached to. Okay, so technically, this side is also adjacent, but since they specified side, you do not give them the hypotenuse. Hypotenuses will be used later in life when we do cosines and sines, but right now we're just doing tangents. Okay? Side opposite the angle in question, side adjacent the angle in question. Okay, we're going to keep going, and we really just have to practice this so that you know how to solve for it. And we're going to go as far as we can today, and then we're going to do a little more next week. There's a triangle that they have drawn, and it looks like this. This is example 1. They've labeled this P, this is R, this is Q. And they gave us some side lengths. The short leg is 36, the long leg is 77, and the hypotenuse is 85, right? They want me to give them the tangent of angle P. Okay? They want me to give them the tangent of angle P. That's this angle right here. What is the measurement of the side opposite angle P, class? Opposite? Yep. No worries. This is opposite. And adjacent is the one next to it, but not the hypotenuse. What's that one? 36. Good. Yes, sir?
So would the answer just be 77 over 36 reduced?
Yeah. We would reduce it. What if they want us to find the tangent of Q? Q is over here. Opposite is? Adjacent is. Okay? Opposite over adjacent to the angle in question. Okay? Why do we care about this? You're going to learn. You're going to find out. Bear with me. I promise you, you're going to find out. Interestingly enough, if I give you an angle measurement, you can actually give me the tangent value from your calculator. Okay, so this is kind of cool. We're at the top of 490. We were just naming information here, and we were saying, I want the tangent of P, and I know this is the length, this is the length. Well, if I don't know the length, but I know the degrees of the angle in question, like say, they say the tangent of an 18-degree angle, you can simply plug into your calculator. And I'm not sure how yours works, but mine, I type in the tan button, right here, the number, and then the equal sign. Oh. Whoa, dude. Okay, so theirs is different. Let's see what I plugged in wrong.
Maybe you should try putting your numbers in, putting 10.
Yeah.
That's what I did.
80 tan equals. Nope, syntax error. Sadie Bell, how does yours work? Because yours is similar to mine.
Yeah, mine goes in the same as that. Oh, wait a minute.
Lovely. Huh.
That's not bad. Oh, mine got it.
Yours got it?
Yeah, I just did the tan and then, are you on the stat?
I don't know. Is that mode
Yeah,
3?
yeah.
And then what do I pick? Which one do I pick? I got,
On that, you just push HC.
whoa. Stat. Okay, so tan 18 equals 0.2. Nope, I still don't get the right answer. Tan 18 close parentheses, still don't get the right answer. All right, so it's obviously set on something weird, which is kind of frightening. Let's all test our calculators. Haley goes 1810 and gets the right answer. All right, test your calculator. Do you get the right answer, Mr. Burrell?
Wait, what are you putting on yours? You putting 1810?
I've done both. I've done tan 18 and I've done 1810.
Right.
You don't get the right answer?
No, I got it.
You got it? Who doesn't get it other than me? Tan 18 equals 1810 equals, nope, syntax error. Lovely. Let's try my other calculator because now that's kind of sketchy. Tan 18. What's the answer?
3.4.
0.32? Okay, this gets the right answer. Why? Okay, anyways, so make sure you test your calculators. Now you're going to say to me, well, Mrs. Myers, what if my calculator whacks out? Well, let's cross that bridge when we hopefully don't get to it. Okay, Sadie, you're going to figure out what's wrong with this other calculator in a minute. How about tan 45? For the calculator that works, tan 45, you should get an answer of 1. Okay, tan 45. Why are you getting an answer of 1, by the way? Because both of the sides are the same in a 45. 45, yeah. It's kind of cool. Let's approximate tan 10 and tan 75. This is checkpoint 2. Is everybody with me over on this side of the room? Let's do tan 10. And they want you to give it to 4 decimals. 0.1763. Tan 75. Did you get 3.732? Okay, 3.732 it is. What's the point? Why do I care? Well, this is where example 3 shows you why this is useful, okay? The tangent of the angle in question is equivalent to the opposite side length divided by the adjacent side length. Okay, you agree with me so far? That's what we've learned. The tangent angle's measurement is equivalent to the opposite side length over the adjacent side length. They've got ourselves a picture there, which I think is really helpful. It looks something like this. And they've just gotten through telling us that this guy here is a 6-degree angle, right? They've also told us, okay, when the sun's rays strike the moon's surface at an angle of 6 degrees, so that tells us the sun's up here, and boom, 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 it strikes the surface, that's the ground, at an angle of 6 degrees, okay? That is where they got that angle measurement. They told it to us. The sun is here, it hits here, and the degree at which it strikes is 6 degrees. They just told us that. When that happens, the edge of the crater casts a shadow that has a length of 4,700 meters. When this happens, this crater, this wall, casts a shadow that is 4,700 meters. Okay? What is the depth of the crater? Okay? We don't know what the depth is, but I can certainly use the tangent ratio, which will give me that information. In order to do that, I'm going to find the tangent of the angle in question, and I will equate it with the value of the opposite angle's length, which we don't know, over the value of the adjacent side's length, which we do know. Okay? Again, the tangent of the angle question is equivalent to the side opposite, which is actually the height of the crater, and we don't know that, but the side adjacent to the angle, which we do know. Tangent of 6. What'd you guys get?
1.15.
Yep. So 0.1051 is equivalent to the depth of the crater divided by 4,700. Now you're starting to see why this is useful? These little cheats are extremely useful. This ratio is extremely useful. When you have a fraction with a missing numerator, you solve by multiplying both sides by the denominator that you have. D then is equivalent to the product of 4,700 and 0.1051. So you got 493.97 and they want it rounded. There's your answer. Okay? So if you know anything about a triangle, if you know an acute angle and one of the sides, you're able to then find out the other side by using the tangent. In the same way, if you knew this, but were curious about that for whatever reason, same exact thing. You would use the tangent of the angle, opposite, adjacent, and solve for whichever ones you were missing. Okay? Say again? I'm sorry, meters. Okay? Well, that is the end of this. Now,